Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 10-6, Theoretical Probability. Alright, you will see that the set theory is useful in calculating probabilities. A set is a well-defined collection of distinct objects. Each object in a set is called an element of the set. As a set may be specified by writing its elements in braces. For example, the set S of prime numbers less than 10 may be written as S equals 2, 3, 5, and 7. The number of elements in a set may be written as N of S. The set S of prime numbers less than 10 is N of S, right? The numbers in set S equals 4. The set with no elements is an empty set and is denoted by a 0 with a line through it, or empty brackets, empty braces, right? The set of all elements under consideration is the universal set and is denoted by U. The following terms describe how sets are related to each other. Okay, so set A is a subset of set B if every element of A is also an element of B. So every element in A falls within B. A is a subset of B. So A is a subset of B. This is the symbol for subset. It's like a little C. It's like a U that's sideways, a horizontal U. The intersection of sets A and B is the set of all elements that are in both A and B. So the intersection is both, right? Where A intersects B. So what they have in both, right? Where they intersect, what's overlapping, the numbers that are shared by both. The union of sets A and B is the set of all elements that are in A or B. All right, so this is and, this is or. So A or B. So you're including everybody. Everybody who's in A and everyone who's in B. The complement of set A is the set of all elements in the universe set U that are not in A. Right, so the complement of set A is everything in the universe that is not A. So we have everything in the universe except things that fall in A. And that has it's like raised to like a little C. Okay? For any set A, what is A intersects empty set? Explain. So in everything in set A that intersects what they have and empty set. Everything in A and nothing. What does A and nothing have in common? So A intersects nothing is going to have in common nothing. Since A and nothing is the intersection of A and empty set, there are no common elements. Right? There's nothing in common between things that are in A and nothing. Recall that the probability experiment is an activity involving chance. Each repetition of the experiment is a trial, and each possible result is an outcome. The sample space of an experiment is a set of all possible outcomes. An event is a set of outcomes. As you saw in the previous lesson, when all outcomes of an experiment are equally likely, the theoretical probability that an event A will occur is given by P of A. The probability of A equals the numbers in A, in set A, over the numbers in set S, where S is the sample space, right? What you want out of everything. Calculating theoretical probabilities. You roll a number cube. Event A is rolling an even number. Event B is rolling a prime number. Calculate each of the following probabilities. So what is the probability of A rolling an even number? Well, how many even numbers are there on a number cube? Well, what are numbers on the number cube? You have 1 through what? You have 1, 2, 3, 4, 5, and 6, right, on a number cube? All right, so what is the probability of rolling an even number? So an even number, 1, 2, 3. There's 3 evens out of 6 numbers, which is 1/2 or 50%. Okay, so the probability of rolling an even number. So in sample space S, we had 1, 2, 3, 4, 5, and 6. A is going to be 2, 4, and 6. There's 6 numbers altogether. We want 3. We want 3 out of 6, which is 1/2 or 50%. Okay? The probability of A union B is the probability of rolling an even number or a prime number. Okay? So A union B, an even number, 2, 4, and 6, a prime number. Is 1 prime? No. Is 2 prime? Yes. 3 prime? Yes. 4? No. 5 is prime. All right, so these are your primes. So B is 3 and 5. A is 2, 4, and 6. So altogether we have 2, 3, 4, 5, 6. So there's 1, 2, 3, 4, 5 of them. So we want 5. And how many are there altogether? 6. 5 out of 6. All right, so we're looking for the probability of A intersect B, right? It's rolling an even number and a prime number. A intersects B. So if A is 2, 4, and 6, and B is 3 and 5, do they intersect? Are there any that are in both? That are in A and B? Which numbers are in A and B? None, right? No, there is one. I didn't write it. What else is prime? 2. So what they have in common is 2. 2's prime and 2's even, right? 2's only divisible by 1 in itself. All right, so how many of them are in common? 1. 1's in common out of the 6 numbers, right? There's 1, 2, 3, 4, 5, 6, 4. And everything. So there's 6 numbers. 1/6. Find the probability of A to the C, right? What was that called again? A to the C was called the complement. So the probability of the complement of A. So everything in the universe that is not an A. Well, what is an A? A is 2, 4, and 6. And our numbers are 1, 2, 3, 4, 5, and 6. So what are in our whole set that are not 2, 4, and 6? Not 2, 4, and 6. So we have 1, 3, and 5. There's 3 numbers we want. Out of the 6 total numbers, that's 1/2 or 50%, right? Explain what the probability of S represents and then calculate this probability. Do you think this result is true in general? Explain. So, P of S is the probability of rolling any number in the sample space. 1, 2, 3, 4, 5, or 6. PF equals 1. This is true in general, since P of S equals NS over NS, which is 1. You may have noticed an example that P of A plus P of the complement of A equals 1. To see why this is true in general, note that an event and its complement represent all outcomes in the sample space. So, where was I? So, the number in A plus the number in the complement of A equals the number in the total sample space, right? So the probability of A plus the probability of A's complement equals the number in A over the sample space plus the number that's not in A, like the complement of A, right? Everything that's not in A over the sample space is going to equal 1. All right, so you can write this relationship as the probability of A equals 1 minus the probability of the complement of A, and use it to help you find probabilities when it's more convenient to calculate the probability of the complement of an event. The probability of an event and the probability of its complement have a sum of 1. So the probability of an event is 1 minus the probability of its complement. Also, the probability of the complement of an event is 1 minus the probability of the event. Right? Everything that's in A versus everything that's not in A. Well, everything in A plus everything that's not in A equals everything in the universe, right? You roll a blue number cube and white number cube at the same time. And what is the probability that you do not roll doubles? Okay, well, I could have rolled a 1 and a 1, or I could have rolled a 2 and a 1, or a 3 and a 1, or a 4 and a 1, or a 5 and a 1, or a 6 and a 1. Okay, gotta roll the 2 second, 3, 4, 5, 6. All right, so I could have rolled a 1 first, and then it's a 1, 2, 3, 4, 5, or 6 second. Could have rolled a 2 first, and then a 1, 2, 3, 4, 5, 6 second, right? So these are all the different possible combinations of what you could roll. All right, so they're saying, what is the probability you will not roll doubles? Well, which ones are doubles? So the probability of not doubles is going to be, it's either easier to find what doubles are and then subtract, right, than to count the others. So look, doubles, 1, 2, 3, 4, 5, 6. There's 6 doubles out of how many? Out of 36. So 6 out of 36 . All right, so what am I doing? There's 6 doubles out of 36, which is 1/6. So the probability that you do not roll doubles is 1 minus 1/6, or 5/6, right? It's easier to find the doubles and then subtract that from 1 to find not doubles. Does that make sense? If 6 out of 36 are doubles, then 30 out of 36 are not doubles. Describe a different way you could have calculated the probability that you do not roll doubles. So you could have done 36 minus 6 and then done 30 over 36 and reduced, right? Use the table to count the number of outcomes in event A, since n of A equals 30, P of A equals n of A over n of S, which equals 30 over 36, which reduces to 5 over 6. So instead of doing 1/6 and then taking 1 minus 1/6, you could have been like, okay, well, if it's 6 of them, then 36 minus 6 is 30. 30 out of 36 is 5/6, and you could have done it that way. Either way, totally works. You have a set of 10 cards numbered 1 to 10. You choose a card at random. Event A is choosing a number less than 7. Event B is choosing an odd number. calculate the following probabilities. So I want you and your table partner to do number 1 really quickly, and then I'll go over it with you guys. How many numbers are less than 7? 1, 2, 3, 4, 5, 6 of them out of 10 total numbers. 6 out of 10 reduces to 3/5. Probability of B, choosing an odd number. 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. That's 5 numbers out of 10, which is 1/2. Try number 3. A union B. Okay, so A and B. A is 3 of them. B is 1 of them, but let's see what they are. So A was 1, 2, 3, 4, 5, and 6. B is 1, 3, 5, 7, 9. A union B. A and B. Union all together. In A or B. 1, 2, 3. What's not in here? 1, 2, 3, 4, 5, 6, 7, and 9. So there's 6, 7, 8. There's 8 numbers in there, right? Out of 10 numbers. So we're missing 8 and 10, right? 8 out of 10, which is 4/5. A intersect B. What is in A and B? Well, in both of them. So 1's in both of them. 3's in both of them. 5's in both of them. And that's it. So there's 3 numbers that are in both, A and B, out of 10 numbers. What about the complement of A? In the universe, but not in A. How many numbers? What numbers? What is not in A? 7, 8, 9, and 10. So there's 4 numbers. 7, 8, 9, 10. 4 numbers out of 10, which is 2/5. Right? Because not in A. A goes up to 6. So 7, 8, 9, and 10. The complement of B, not in B. The evens. 2, 4, 6, 8, and 10. 2, 4, 6, 8, 10. There's 5 numbers out of 10, which is 1/2. A bag contains 5 red marbles and 10 blue marbles. You choose a marble without looking. Event A is choosing a red marble. Event B is choosing a blue marble. What is the probability of A and B? A intersects B. All right, well, A is choosing red. So there's 5 reds out of 15, right? B is choosing blue. There's 10 blue out of 15. But here's the thing. A and B, can they be red and blue? You're not going to have any overlap. What's going to overlap? A is reds, B is blue. There's none of them that are the same. So empty set, right? A intersect B equals 0. Empty set. Since a marble cannot be both red and blue. What they have in common. Red and blue have nothing in common. A standard deck of cards has 13 cards. In each of the 4 suits. You choose a card from a deck at random. What is the probability that you do not choose an ace? Well, how many aces are there? Hearts, clubs, diamonds, and spades. How many aces are there? There's an ace of hearts, an ace of clubs, an ace of diamonds, and an ace of spades. There's 4 ace cards, right? 4 are aces out of how many cards in the deck? 13 times 4, 52. So 4 out of 52 are aces. So the probability that you do not choose an ace. Well, if 4 are aces out of 52, how many are not aces? What is 52 minus 4? So 48 out of 52 are not aces, and that reduces to what? Out of 13. So 12 out of 13. Make sense? 12 out of 13 are not aces. Well, think about it. Obviously, it's going to reduce to that. 12 cards out of 13, and they're in each suit, but it reduces, you know? You choose a card from a standard deck of cards at random. What is the probability that you do not choose a club? Explain. How many clubs are there? I mean, you could think of it this way, too. Clubs are what percent? There's 13 hearts, 13 clubs, 13 diamonds, 13 spades. So not a club, 52 minus 13. 39 are not clubs out of 52 total cards. That's 3/4. Doesn't that make sense? 3 out of 4 different suits, and there's an even number of each suit, right? A bag contains white tiles, black tiles, and gray tiles. The probability of white, the probability of choosing a tile at random and choosing a white tile is 1/4. The student claims that the probability of choosing a black tile is 3/4. We have white, black, and gray. Well, if black is 3/4 and white is 1/4, then that means there's no gray, right? No. Choosing a black tile is not the complement of choosing a white tile, since the bag also contains gray tiles. It is not possible to calculate P of B from the given information. They didn't give you enough information, right? We don't have enough information. So, your homework tonight is 593 and 594. 593 and 594. in your workbook. I hope you guys enjoyed today's lesson. Please like and subscribe and have a fantastic day.